Hello everyone, I am Sandhya Rani from Vignan Institute of Engineering for Women. I am taking a machine learning with Python course from Skyfi Labs, and as a part of it I am assigned to do a project, and my project is about iris prediction. This project is used to predict the species of a flower. And now coming to our project, first we import all the required packages as shown, and the first step in the machine learning is data pre-processing. For that, load the dataset, and in order to get the description of the dataset we are using DESCR keyword, and this is the description of our iris dataset. The iris dataset consists of 150 instances and 4 numeric attributes and a class predictive attribute. This class predictive attribute consists the species of the flower. And next, put the data into the pandas data frame as shown, and we can view the dataset in the data frame format. We can perform a simple query on the features data frame by viewing the petal length column as shown, and then store the target into another data frame called target. We can view the target column. Now we can perform queries on the target data frame in order to view the minimum and maximum value in the target column as shown. Now concatenate the features and target into a single data frame by using the concat function which is provided by the pandas package. Here axis is equals to 1 is used to concatenate two data frames into a single data frame in side-by-side format, and we can view the target column is added at the end of our data frame. And next, calculate the correlation. Calculate the correlation between every column of the data and store it in core variable. Take the absolute values of the correlation. Next, make a list of pairs of core and features and store it in L variable. We had used zip function in the Python in order to make the list of pairs. Then sort the list of pairs in descending order. Here we use lambda function which helps us to sort the keys. Now unzip the toList. Then plot the correlation with respect to the target variable as a bar graph. We had used all the functions which are available in the matplotlib library. Now here we can visualize the graph. Here petal width attribute has the highest absolute correlation value, and we are choosing this attribute as the independent variable for our linear regression model. And our next step is the normalization of the data. We perform normalization by using min-max scaler which is provided by the sklearn package. Firstly, we are initializing the x and y variable as shown, and we can visualize the data before normalization that the data is in some arbitrarization. Now perform the normalization by using min-max scaler and using fit transform function to reshape the values of the x column and y column. Here we are performing the slicing operation because after normalization an extra dimension is added to the values. So in order to remove it, we are performing the slicing operation, and after normalization of the data we can see the values of y column are only in the range of 0 to 1. Next, our second step in the machine learning is to define the error function as follows. Now the third step is splitting the data into training and testing data. Here cross validation is also performed in order to improve the accuracy and performance of our model. Now split the data into two fixed sets as follows. We use train test split function in order to split the data. Then the fourth step in the machine learning is to train the model. Here we are using the gradient descent function, update function and error function, which are updated by the gradient descent algorithm. Here we are using the gradient descent algorithm for our machine learning model because it is an optimization model and it is used to minimize the cost function. Here the update function, error function, gradient descent function are mentioned as shown. Now initialize all the values and call the gradient descent function in the correct order of parameters. Now here, in order to reduce the number of iterations and processing time, we perform slice operation. Now in order to plot the graph and generate the animation, we use subplot function, and it uses two functions, init function, update function, in order to generate the animation. And finally we had generated the animation and the plotting of a linear regression model, and the next step is to visualize the learning process. Firstly we have to plot the regression line and plot the change in regression line through the training process. First plot the regression line upon the training dataset. For that we use scatter function and the plot function as shown, and the plotting is done as follows. And the final step in the machine learning is prediction of the model. It needs 4 steps. First step is to initialize the predicted values by using x-test, m and c values, and next reshape the values of predicted x-test and y-test, and next perform scaling and normalization on the x-test, y-test and predicted values, and next perform the slicing operation in order to remove the extra dimension which is added after the normalization. Next, calculate the prediction on the test dataset as a vectorized operation as follows. Now calculate the mean square error on the testing set, and this is the mean square error function. We used mean square error function in order to make easy of our predictions. Now put the x-test, y-test and predicted into a single data frame by using the zip function. We had done this step in order to visualize the data, that how much the predicted values are closer to the target values, and from the output we can see that the predicted values are nearly closer to the target values. And now plot the predicted values against the target values, and the plotting is as shown. Next, reshape the values as before. We don't need the normalization values, so hence we are reshaping the values as before, and hence from the output we can conclude that the predicted values are nearly close to the target values, and we had predicted the iris successfully. Thank you.